Hi, we have a calculus problem here. We are told to find the derivative with respect to x of the following, and we are asked now to simplify. Part A says the following: y equals e to the 1 plus secant squared x. So how do we go about solving this? Well, let's first remember the basic function e to the x. How do we find the derivative of that? Let's recall d with respect to x of e to the x is simply e to the x. It's just itself. Now, what if we have a function of x? Because keep in mind, e is being raised to a function of x here, not simply x. What do? Well, we apply the chain rule with respect to taking derivative of e to any power. We have e to the u of x here, and remember that simply e to the u of x times u prime of x, so derivative of u itself with respect to x, which if you look at it, that's basically what we have here, except our u is x, so what's the derivative of x with respect to itself? 1. So it's essentially the same. So what do we do here? Well, we're going to apply the same. Keep in mind, this is our u of x. So we basically substitute our derivative of y with respect to x, then, is going to be e to whatever power times the derivative of that power to x, whatever variable we're asked to differentiate with respect to. Now the next question is, what is the derivative of 1 plus secant squared x with respect to x? Well, keep in mind the property of differentiating sums. In this case, we know the derivative of 1 with respect to x is 0. So that goes to 0. We focus on this. Remember, secant squared x is simply secant of x in the whole quantity squared. How do we find its derivative? The derivative with respect to x of secant x quantity squared. We use the chain rule. 2 comes here. That becomes a 1, leaving 2 secant x. Now outside inside, times the derivative of what's inside. What's the derivative of secant x? It's secant tangent. So we'll multiply that by secant x, tangent x. And we're done as far as that's concerned. Now what do? We simply substitute that in here. We take all of this and plug it in. We get 2 times secant x times secant x tangent x, and we're asked not to simplify, so that's our final answer. This is good enough. And that's part A. Thank you. For part B, we're asked to find the derivative of y equals x times natural log of cosine squared x over 2. So like I always stress to students, we don't panic because a problem might look difficult. In math, we always try to look at the big picture and work our way in. So keep in mind, the rules of math never change. Try to focus on the structure, the general pattern. So what's the big picture? Well, we have y equals something times something. So that tells us right away we're going to use the product rule because we have two things we're multiplying. And what does the product rule tell us as far as taking derivatives? Well, how I like to think of it, there are several ways to write the same thing, but one way is the following: uv quantity prime equals u v prime plus u prime v. I've seen other ways to basically say the same, like f g prime equals f g prime plus f prime g, same. So now, the u and the v's themselves might be functions of x. It really doesn't make a difference. It's just, in general, they can be x, as in this case, our u is directly x. And then this here, the whole thing, is our v. So u is just x, v is a function of x. They're technically both functions of x, but u being x makes our job a lot easier. So what do we do here? Well, uv prime is u times v prime plus u prime v. So let's go ahead and substitute here. So our u is x. So according to our formula here, we've got x times v prime. So now that's going to be this derivative. Now, just because this might be a little more complicated, doesn't mean we panic. Again, we look at the big picture and we work our way in. What I know I have here is the natural log of something. Well, how do I know how to deal with natural logs and finding their derivatives? Well, the rule tells me that the derivative of any natural log is simply 1 over whatever it is we're taking the natural log of times the derivative of that thing. So in this case, we have our u prime here. Let's go ahead and figure out what v prime. We have our u rather. Let's go ahead and figure out what v prime is. So I was saying we have 1 over everything we're taking the natural log of, and now we take the derivative of the cosine squared x over 2. Now what is that? Well, cosine squared x over 2, that's just cosine x over 2 quantity squared. Cosine of x over 2 quantity squared. What is the derivative? So we know we are going to take, what we basically have is this, cosine of x over 2 quantity squared. Again, we use the power rule, we'll work our way in. We're going to use the chain rule. So according to the power rule here, this is going to be 2 times cosine of x halves to the first power times the derivative of what's inside. What's the derivative of cosine? It's negative sine. And we're not done yet, because we still have to worry about this x over 2 and take its derivative. And derivative of half of x is simply half. So now, that's the derivative. I should actually have written this. First derivative with respect to x of this is all this here. So now we simply multiply that by this. Well, one easy way to save space, instead of writing all this here, I'm simply going to put it over here because we're multiplying by 1. So I'm simply going to write 2 times cosine x over 2 times negative sine x over 2 times half. And we notice the half simplifies with this 2. We're left with that. So that's our u v prime. Now, plus u prime v. So our u is x. Derivative of x with respect to itself is just 1. So it's just going to be a 1 times v, the whole quantity. We don't have to bother doing anything except writing it. Natural log of cosine squared x over 2. And we're told not to simplify, so there's our final answer right here. And as a matter of fact, we actually didn't even have to cancel anything out. As long as we understand the process is what the examiners, or is what the question is really testing us on. So it's all about knowing what to do and not getting confused with the steps, not really about simplifying the details. So thank you, that's our part B. Thanks a lot. For part C, we're asked the following. Y equals 10 to the tangent of 3x plus 1, the whole quantity, find its derivative. Again, we look at the big picture and work our way in. What does the big picture say? Well, we have y equals some constant to some power. How do we deal with finding derivatives of a constant raised to a power? Let's remember the formula. If we have a to the u, so derivative with respect to x of a to the u is simply going to be a to the u times the natural log of a times du dx. It's our formula. So all we do here is simply use that. We just need to identify our a and u. Our a, 10. This will be our a, and this is our u. So how do we find dy dx? Based on this, dy dx then is going to be so the same a to the u, exactly the same thing. 10 to the tangent of 3x plus 1. So we have our a to the u, and we multiply by the natural log of a, which is going to be the natural log of 10, times du dx. If our u is tangent of 3x plus 1, what's du dx? Tangent, we work our way in. Tangent has a derivative of secant squared. So secant squared 3x plus 1 times derivative of this. What's that? That's 3. With respect to x, derivative of 3x plus 1 is 3, and we're told not to simplify, so we are done. We can't take it any further than that. Part D, our final part, is a little more involved. We have a quotient here and a log with a base of 2. How do we find that? We have two formulas to help us. Here's the quotient rule that reminds us of taking derivatives of quotients, and then here's a formula for finding logs with base A. So when I deal with the quotient rule in derivatives, I like to take care of the v squared and just get it over with, so it's done. It's kind of easier for me. So I have my v square root of x plus 1, so that's a quantity square root of x plus 1, quantity squared. Now let's worry about the numerator, which says v, which is simply this, times the derivative of u, the numerator. Well, how do I find the derivative of a log with a base of 2? I use this formula, where 2 in this case is a, and u is going to be x cubed plus 1, whole quantity. It tells me it's going to be 1 over natural log of a, so that's 2. So 1 over natural log of 2 times 1 over u, that's what comes after the base. So 1 over x cubed plus 1 times the derivative of u with respect to x. Derivative of this with respect to x is just 3x squared. Minus u, which is numerator, times derivative of denominator. The numerator, we just simply write everything we have there, log base 2 of x cubed plus 1 times derivative of this. Keep in mind, this here is just x to the 1/2 power. What's that derivative? It's going to be 1/2 x to the negative 1/2. That's a 0 when you take its derivative, and that's it. We're done. For number 2, we're told to solve the initial value problem for y of t, where dy dt equals e to the t times secant squared e to the t plus pi over 8, and y of natural log of pi 8 equals 4. The only way to find y, if you know its derivative, is to integrate. We're going to have to find the integral of this to find y. The best way to solve this problem is by doing u substitution. And u sub is about just looking for patterns and things that just kind of make your problem easier. What I'm going to do here is I'm going to say u equals e to the t plus pi over 8. So that's my u of t. So du then is going to be, remember our formula for finding derivatives when we have an e involved. This is simply going to be e to the t. That's a constant, goes to 0, so dt. So if I know y prime, y is simply going to be the integral of all that. Y is the integral of y prime. So y is simply the integral of e to the t times secant squared e to the t plus pi over 8. Y is simply the integral of this whole quantity, e to the t times secant squared, e to the t plus pi over 8. Now let's go ahead and substitute u's here where we see them. And let's not forget our dt here. Now what's our u? Keep in mind, this is u here. This is u. What we essentially have here is y equals the integral of secant squared u du. So secant squared of u du. How do we integrate that? Well, the integral of secant squared is tangent. So y equals tangent of u plus c. Tangent of u plus c. And let's back substitute for u. We know u, we've defined it to be that. So y equals the tangent of e to the t plus pi 8 plus c. Now we have an initial value problem. For initial value problems, we cannot leave any constants of integration. We must figure out what they are. And all we do to find them is just substitute. So we simply plug in, for a y, we plug in what we're given. For a y, we plug in 4. And then for independent variable, we plug in natural log of pi over 8. Do the math, and we'll figure out our c. Let's go ahead and do that. 4 equals the tangent of, so that's what we have for y. So let's go ahead and plug it in. Instead of y, I plug in a 4. Tangent of e to the t. So instead of having a t, I'm going to write natural log of pi over 8. That's our initial t. When I plug in t, which is this, I get in 4 for y, plus pi over 8 plus c. So y equals tangent of that plus c. Plug that in. Let's see what happens here. We have 4 equals e to the natural log of anything. They cancel each other. That just gives me tangent of pi over 8 plus pi over 8 plus c. Pi over 8 plus pi over 8 gives pi fourths. Pi over 4 plus c. This is a 1. 45 degrees, pi over 4. Its tangent is 1. So that gives 4 equals 1 plus c, which means c must be 3. Let's go ahead and simply substitute our 3 for c. We have our final answer. We get y equals tangent of e to the t plus pi 8 plus 3. And there's our final answer.